The software development landscape has undergone a seismic shift, creating what can only be described as an existential imperative. With 95% of developers now utilizing AI tools weekly, and a quarter of the latest Y Combinator batch possessing codebases that are nearly entirely AI-generated, the market has exploded from $4.9 billion to $30 billion. For founders, the question has evolved from whether to adopt these tools to strictly determining which terminal-native solution to deploy immediately.
This shift moves us far beyond simple browser-based autocomplete or vibe coding used for quick prototypes. We are entering the era of the Agentic CLI, where continuous React loops run directly in the terminal for production and orchestration. These agents don't just suggest code, they autonomously observe the environment, plan multi-file changes, execute shell pipelines, and run tests, effectively functioning as headless CI/CD operators.
This technological leap creates a new math for startup engineering, embodied in the 10-100-3 framework. 10 people generating $100 million ARR in just 3 years. This efficiency is driven by a massive multiplier effect, where a single AI-savvy engineer matches the output of 5 traditional developers. The focus shifts from velocity to volume, allowing teams to tackle expanded scopes and tasks that previously wouldn't have been economically viable.
As the market matures, 3 terminal-native giants are converging to dominate the space: Claude Code, OpenAI's Codex CLI, and Google's Gemini CLI. While they all perform comparably on straightforward terminal tasks, hovering around 53% success on terminal bench hard, they diverge significantly on complexity. Currently, Claude leads the pack in handling the multi-step reasoning required for complex software engineering benchmarks. Claude Code positions itself as the premium orchestration tool, boasting a 75% adoption rate among startup developers. It differentiates itself by running multiple instances on separate threads and accessing thousands of external tools via MCP. However, this deep reasoning capabilities and enterprise compliance focus come with a trade-off. It is the most expensive option, with serious users needing plans costing up to $200 per month. In contrast, OpenAI's Codex focuses on secure, parallel execution. Built on a sandboxed Rust core, it excels at cloud-based asynchronous bulk processing, allowing it to handle dozens of tasks simultaneously. It offers high value by being bundled with the standard ChatGPT Plus subscription, making it a versatile workhorse for bulk operations, though it requires careful version control due to slightly shallower reasoning. Google's Gemini creates a unique niche by leveraging a massive 1 million token context window. Its Jules agent acts as a fire-and-forget system that clones repos into a secure VM to work independently in the background. While it has a higher error rate and slower startup times than Claude, its generous free tier and ability to ingest massive monorepos make it dominant for large-scale maintenance tasks. However, relying on these agents introduces systemic risks akin to hiring an army of juniors. Because these agents often avoid refactoring, they can produce verbose code slop that technically compiles but creates architectural debt. Furthermore, without proper guardrails, they introduce security vulnerabilities at a higher rate than humans and can cause massive, unpredictable bill shocks due to API usage spikes. To mitigate these risks, engineering leaders must align their constraints to the right agent. The optimal strategy is not to pick a single winner, but to leverage complementary strengths. Use Claude for quality and complex reasoning, Codex for versatility and parallel tasks, and Gemini for massive context and budget-friendly scale. In reality, most developers now utilize 2 to 4 of these tools simultaneously. Consequently, the role of the developer is permanently shifting from a craft model to an orchestration model. The new archetype is a T-shaped generalist who designs system architecture and configures agent swarms, rather than writing every line of code. The directive is clear. When AI writes bad code, you don't fix the code, you fix the prompt, update the rules file, or engineer a better subagent. Navigating this transition from coder to orchestrator requires a new kind of expertise. Imbala.ai positions itself as the studio for this AI-powered consulting, helping organizations learn the new toolsets, build efficient agentic workflows, and transform their engineering culture to thrive in this automated future.